Hello and welcome again to our second video on solving multiple choice questions involving salts and salt preparation. Now in our first video we tackled 6 different types of multiple choice questions, and in this video we shall do another 6 of a different variety. Okay, so let's take a look at question number 7. Okay, now before that, maybe it is good for us to recap that in order for us to be able to solve this kind of questions, we need to have a good understanding on our solubility of salts, okay, as well as the different salt preparation methods. So let us now begin. Question number 7. When an excess of aqueous potassium iodide is added to mercury chloride, the following reactions occur. So here we see that mercury chloride reacts with potassium iodide to give you mercury iodide and potassium chloride, and then there's a further reaction of mercury iodide and potassium iodide to give us this new complex compound. Okay, now the question says, which one of the diagrams shows us the mass of the precipitate, how the mass of the precipitate varies with the volume of the aqueous potassium iodide? So it may look pretty complicated, but let us see whether we can break down this question part by part. Okay, now we realize in the first equation, we realize that we are first of all reacting an aqueous substance with another aqueous substance to produce a solid, which means this substance is a precipitate. Since we are starting with two soluble materials here, and we end up with a precipitate, which of the following graphs may give us some clue as to the answer? Now, since we are starting with two soluble materials, here there should be 0 precipitate to begin with. Okay, there is no precipitate to start off with. Okay, so since the graph all shows here the mass, starting mass of the precipitate, the only graph here that shows us where the precipitate starts from 0 is actually D. So we have effectively solved the question. But let us see whether our answer D really matches the answer. Now we started off with two soluble materials and we got a precipitate. This causes the mass of the precipitate to increase initially from 0. And when we continue to add more potassium iodide, we realize that the product here is soluble, which means the precipitate has dissolved. If the precipitate has dissolved, which means the graph will go down and the mass of the precipitate will reach to 0. Okay, so basically the idea of this question is to show you that even though the stem of the question may look pretty complicated, by looking for simple clues within the question itself and understanding the use of the graphs, it is not that difficult to answer. Okay, so as usual, you can pause and rewind any part of the video to allow you more time to absorb certain parts of the question. Okay, so now let's take a look at question number 8. An excess of sodium sulphate is added to barium nitrate and the precipitate of barium sulphate is filtered off. What will the filtrate contain? So let us take a look. We are reacting sodium sulphate with barium nitrate. So let's write the equation. If we have sodium sulphate reacting with barium nitrate, we should get a precipitate of barium sulphate as mentioned, and we should get sodium nitrate. Okay, this is your precipitate. Now, since we are adding these two, we will get barium sulphate in your as your precipitate. Now we are adding excess sodium sulphate, right? So when we add these two, we will get the precipitate of barium sulfate, which is your precipitate, and your sodium nitrate, which is the aqueous portion. But since we are adding excess aqueous sodium sulfate, as written here in the question, there will also be excess sodium sulfate in here also. Okay, now if you were to take this mixture and you filter it, the residue will contain barium sulfate, but your filtrate will contain the original sodium nitrate and the excess sodium sulfate. So these two will end up in your filtrate. Okay? So the only one that matches here, sodium nitrate and sodium sulfate, will be D. Okay, so let's go and do one more question. A salt is prepared by reacting an acid with a base. The titration method of preparation is used. Which of the acid, base, and salt makes this method possible? Now, the question already tells you that it is a titration method. Therefore, we are looking at a soluble salt. Okay, so the salt itself has to be soluble. So that means C is out. And for the titration method, where it usually involves using a burette and titrating it with a conical flask, allow me to draw perhaps a slightly better conical flask, means we have to start with a soluble material in the burette and a soluble material in the conical flask. So the two starting materials has to be soluble. So that means acid soluble, base soluble, salt soluble. Answer is therefore D. Let us move on to the next question. How can lead 2 sulfate be best prepared from lead 2 oxide? So again, we want to prepare lead 2 sulfate. And let us recall what kind of salt is lead 2 sulfate. We remember that all sulfates are soluble except calcium sulfate, lead sulfate, and barium sulfate. So that means lead 2 sulfate is an insoluble salt. And an insoluble salt, usually the starting materials has to be two solutions. So we start with two different solutions. So, but here we are given lead 2 oxide, which we know is insoluble. So we have to convert the lead 2 oxide into a soluble substance first. Okay, and how can we convert lead 2 oxide into a soluble substance? Now we recall which lead salt is soluble. Okay, now we remember that lead nitrate is soluble because all nitrates are soluble. So if we add nitric acid with lead oxide, we should get our soluble salt of lead nitrate. And now guess what is the remaining product? This is a reaction between an acid and a base. So we should get salt and water. So we balance the equation by writing a 2 there. So now we have our soluble lead nitrate, which we can then add a sulfate to produce lead 2 sulfate. Okay, so the best option here would be adding dilute nitric acid to the lead 2 oxide to produce my lead 2 nitrate, and then from lead 2 nitrate we add sulfuric acid. We add sulfuric acid to lead 2 nitrate. This will give us our insoluble lead sulfate and remaining nitric acid again. So How do we produce lead 2 sulfate from lead 2 oxide? We react the lead 2 oxide with nitric acid, and then which gives us lead nitrate. We take the lead nitrate and we react with sulfuric acid to form lead 2 sulfate, the insoluble salt. Answer is therefore D. Okay, let's go to the next question. The table below shows the solubility in water of some nickel compounds. Which method is used to prepare nickel 2 chloride? So we are given a table of different nickel compounds and we want to prepare nickel 2 chloride, and we realize that it is a soluble salt. Now we know that it is a soluble chloride, and all chlorides are soluble except lead and silver. So this is a soluble chloride, but it is a non-spar soluble. Okay, non-spar soluble, which means we need to react an acid with an insoluble metal, base, or carbonate. Okay, so which of these options best fits the description for the preparation of a non-spar soluble salt? So let's go through one by one. Warming nickel oxide with hydrochloric acid. We know hydrochloric acid is an acid and nickel oxide is an oxide of a metal, so this is a base. So acid and a base. Hey, that looks correct, but is nickel oxide an insoluble base? We can see here that nickel 2 oxide is an insoluble base. So adding acid with an insoluble base will give us our non-spar soluble salt. So automatically your answer is A. Now let us see whether it's really true that the rest cannot be. Okay. For B, titrating nickel 2 hydroxide with hydrochloric acid. Now in order for us to prepare to do titration, both materials must be soluble. Since we know hydrochloric acid is soluble, but nickel hydroxide is only slightly soluble. So we cannot do titration with something which is only slightly soluble. Okay. C, adding sodium chloride with nickel 2 nitrate solution. Now again, if we want to see, we will get nickel chloride, but we will also get sodium nitrate, both solutions, both soluble substances. We will not be able to separate our nickel chloride from sodium nitrate. So C is out. Okay. For D, it says precipitating the salt. Now we know that it is a soluble salt. Therefore, we cannot use the precipitation method to prepare a soluble salt. So the answer is A. Acid, hydrochloric acid, and an insoluble base like nickel 2 oxide. Okay. And let's do our one last question before we end off this video on salt preparation methods. Number 12. The diagram shows the steps involved in the preparation of a salt. Now you notice that step 1, there is some solid material which we are pounding into a more powdering form. Step 2, we are heating with another substance, a liquid, and we are stirring. Step 3, we are filtering. And step 4, we are heating. So all these steps are relevant to the preparation of a non-spar soluble salt. Okay, non-spar soluble. So which of these are non-spar soluble? We know that barium sulfate, all sulfates are soluble except calcium, lead, and barium. So we know that this is an insoluble salt. So A is out. Copper 2 sulfate. Copper 2 sulfate is a soluble material, and since it is not sodium, potassium, or ammonium, we know that it is a non-spar soluble. And this is what we are looking for, because both potassium and sodium sulfate are spar soluble. in which case we use the titration method. So C and D are also out, giving us the answer of B, copper 2 sulfate. So these are another 6 questions of different style, all on the method, all on the topic of salt preparation. I hope that this video has allowed you to go through the thought process required to answer questions related to salt preparation techniques. Okay, so hope that you've been able to understand, and look out for our next video. See you soon. Bye bye.